Good morning, year 11. I hope you are doing well and enjoying the summer holiday. So today what we're gonna do, I'm gonna present you a video. I'm gonna present you basically the A-level physics course, and I will show you as well basically what are the different routes that you can take if you do A-level physics. And the last part will be to show you one like a lesson about year 12 contents, and we're going to end up by doing a practical. So and route to innovation and level physics, and what is it? So it is basically, if I quickly define what is a physics contribute to the technological infrastructure and provide a trained personnel need to take advantage of the science advance and discoveries. So we know basically physics is taking part of the different and basically innovations like quantum computers, like technology infrastructures, and so on. And as well, we know physics takes part of like all the innovation, the discoveries in space. Okay, and finally, basically, what we have as well, the physics and the telecommunications. So we know anyone who does an A-level physics can easily be selected to do and for an basic for a degree in a telecommunication, and as well physics is linked to the engineering, and as well today what we have got the physics is as well linked to the environmental and basic technologies and how we can use any renewable energy source. Okay, so the future physics as well take part a lot about the future, and this is here, so I can show you a preview of what it's going to look like a driverless car, and as well the 6G. Currently we're using the 5G, but basically and actually all the research are taking part as well, like to the and how to develop the 6G of internet, okay, and telecommunications. So in Ashton Park, you will be taught by me as a specialist physics teacher, and as well with the collaboration of the Institute of Physics. You will be in a reduced class in the sixth form. The maximum number that we can take in one class is 15. This year we had a student who had my full attention, but as well like giving a plenty of support. Okay, and then you will be in a familiar environment, okay, as you are in Ashton Park School. So, what is the content? So, the physics and A-level physics is 2 years a linear course. Okay, so this is what it look like the textbooks. I've chosen the AQA textbooks for the continuity, because if you remember, you have done in AQA Key Stage 4 in Ashton Park. If you're coming from another school, so if you're doing AQA is good. If not, it doesn't matter. Is there's a trust, but pure basically and familiarity that I've chosen the AQA physics. Okay, anyone who's coming from another school who had Excel or the OCR as exam board can as well do the AQA physics. There's no basically a barrier, okay, as you have covered all the key stage 4 physics content. So the exam by the end of the year, you will have a 3 papers: paper 1, paper 2, and paper 3, and each one will be in 2 hours. And as well, we contribute to a final percentage, to a final score. In terms of how the percentage is divided between the 3 papers. So you have got 34% for the first paper, 34% the second paper, and 32% for the last paper. Okay, each paper, paper 1 and paper 2, will assess a section of the content. Example, section 1 to 5 will be assessed, and as well the first chapter of the section 6 will be assessed in paper 1. Now just the chapter from 6.2 to the units and 8 will be assessed in a paper 2. And now the section 9, 10, 11, 12, or 13 will be assessed in a basically in a paper 3. Okay, And so that is basically why and how the marks are contributed and how the marks are divided and percentage of the score. So now this is an overview basically of the course. If you want a more detail, you can Google and directly go on the AQA website, A-level AQA physics, and you can see what are the different layout or the different chapters that are in each section. Okay, so and yeah, that is basically how it look like the content. So now what we're gonna do, I will show you a lesson. I will teach you the content, and then you will see that. And after all, basically, the A-level physics is a course as the others, and the courses is not that hard. Okay, it's an elite course. It is among the best courses, A-level course in the world. And but however is present the similar challenges as the other courses. Okay, so this is the lesson. It is an A-level taster. So what is it? This is basically the lesson here. The title of the lesson is how to determine the gravity, the value of gravity by the freefall method. We know the value of gravity on Earth is 9.81 and the Newton per kilogram, or 9.81 the meter per second square. Okay, and we call it as well a basic acceleration due to the gravity. Okay, so we're going to look at how we can determine that value, so using the method of a free fall. So where is this lesson? This lesson, it is part of a chapter 7 of the year 12 content, okay, in the unit 3. That chapter 7 is called On the Move, and as well is taught as well and cover as well during like a required practical. Okay, and that is the required practical number 3, or a core practical for anyone who's coming from the edXL key stage 4. So here it is. If we quickly look, what is the theory behind? Okay, a free falling object means one that is falling vertically under gravity. So we know when someone is jumping from a plane, can go under free fall. Okay, a free fall, and we know as well it will when the air resistance is basically balanced by the gravity, that so that object will reach a terminal velocity. Okay, but and so and if basically and so what we're gonna do, so in reality, so in practice, every object that is falling in the air will experience air resistance, but provided the object is made of a dense the material and its speed is not excessive, it may be considered to be falling freely. Okay, so as this object will basically and will have a considerable and mass, and as well will move as a constant velocity, we will consider this object is falling freely. Okay, and we can then apply the equation of the uniform acceleration. Okay, and so in particular, like basically in particular, we're going to use this equation. The displacement that will be equal by the initial velocity that's jumping from the plane times the time it will take to reach the floor, okay, or the ground, added to the half of the acceleration times the time square. That is the equation of the uniform acceleration that we're going to use in a free fall condition. The acceleration will be equal to the acceleration due to the gravity, which is the gravity. Okay, so that is the theory behind. That is the setting the scene, okay, of the free fall, and these are the different quantities that will be involved, okay, and the equation. Now then, if we try to simplify this equation, okay, by removing the half, and how we can do that, you have learned in key stage 3 and key stage 4 how we can basically remove a fraction from an equation. Here is basically is half, so what we can do, we can all divide it all time we can all times by 2. Okay, if we times by 2 here, we're going to times by 2, and that will remove the fraction, and we're going to have 2 times s equal 2 times the uniform acceleration times the time, plus the acceleration times the time square. Okay, so then if we again simplify by dividing the whole quantity, the whole equation by the time t, we will have 2 over t here times the displacement equal 2u. Okay, we have removed the times because we divided by time the whole thing, plus at. Hopefully is it clear the way I simplified my equation here. So this is where will be very interesting. Now this equation can be represented by a straight line equation. You have learned in key stage 3, so a straight line equation, okay, or a line graph can be represented by y equal mx plus c. Here the y will be basically equal to the 2 over t times the displacement. That can be considered as a y. This quantity can be considered as a c, which is the y-intercept, and this can be considered mx, with m the gradient equal to the acceleration, and the time will be the independent variable, which is the value x, can be represented by the value x. All right, so that is where we are. We have simplified that, and then that's where we are. Now then, let's look how this can be applied to a practical, and how can we determine the value of a, the value of acceleration due to the gravity, which is equivalent to gravity, okay, using a practical. This is the equipment that we're going to use. So we're going to use a freestyle, actually basically a ferrite stand, hold an electromagnet, which is a magnet that will be on, okay, when we turn on the electricity. You have learned again in year 11 and as well in year 8. Okay, that will hold a steel ball. We know steel is a magnetic object, so therefore will be attached to the electromagnet when it's on. Okay, so a first light gate, a second light gate. Now the distance between the electromagnet and the first light gate has to be fixed, same, with no change during the whole practical. But what we're gonna move, we will vary, we will change the distance between the first gate and the light gate by moving up the second light gate. Now, how the whole system will work. When we open the switch, when we turn off the current supplied by the DC supplier, the electromagnet will release the steel ball bearing. The steel ball bearing will go through the first light gate. The first light gate then will trigger a stopwatch, and we start to count until the ball will basically reach the second light gate. When we reach the second light gate, the second light gate will stop the stopwatch, and therefore we'll have the time here, right? So that is for a distance. We're going to start by first distance of 50 centimeter, okay, and then we will repeat the same practical by varying, by changing the distance between the two light gates. We will move up by 5 centimeters. And then we will keep change, and then we're going to do the whole experiment again. We're going to take the value of the time, okay, and so on, okay. So that is it. So then, here it is. If we basically, and if we basically now, and it should be visible. There you go. If I remove that, remove that, remove that, remove that. Okay, so there you go. If we basically now represent, if we collect our data in a table that for the different time, how much will be the two times the distance between the light gate divided by the time, and then if you have got those data in a table and we plotted our graph, we will obviously have a straight line graph. That straight line graph, Okay, so we know the first point here, this will be the y-intercept, which is the 2u. And from the line graph, we can determine the gradient of the line by choosing 2 points. And then how we calculate the gradient, you already know it. Actually, you have learned key stage 3 and key stage 4, which is the distance between the 2 point, the height, the change in y, the change in the value of the x, what the y-axis, divided by the change in values, the change in the change of x, right? That will give us our gradient, and that gradient will basically be equal to the acceleration due to the gravity. That is how we determine the value of gravity by doing a freeform experiment. Okay, and this is showing as well, this is not a lesson that is not covered in year 12. It is actually a lesson in year 12 showing you the challenges are basically not that much hard as we think. It is applying what you have learned in key stage 3 and key stage 4, and mainly it is accessible. Okay, so I wish basically you will enjoy my video, and as well you will consider taking A-level physics in Ashton Park. That is all from me. Thank you.